My dear friends, welcome back to BSpice. In this session, we'll continue with substation automation. In fact, this is the final part wherein we'll focus on IEC 61850. So you may ask if we have already covered, no. Actually, what we have covered is on the concepts actually. So, but in this session, we are going to talk about objective, benefits, protocols, and of course, the final, what is the benefit? Comparison between the conventional and the substation automation system. Okay. So if you are a first time viewer, wanted to inform you, friends, we have covered this in part 4 parts, in fact. So earlier, 3 parts we had already uploaded. So the first part talks about how substation works. Then the second part, we talked about the substation automation evolution and digital substation. Then the third part, we comprehensively covered the architecture in line with process level, bay level, and station level. So if you are not watched, you can watch, friends. This is very important, even though it is more of we belongs to INC, but I suggest we should also know this substation automation. Some cases we also need to involve in this. Okay. So with that good note, I will go into the topic. Okay. So IEC 61850. Okay. Just our intro, friends, again. It's a flexible and open standard that defines the communication between devices in substation automation system. So that is what it is used for. Okay. Then to enable seamless data communication and information exchange between the overall network. Then IEC 61850 is the most recent standard for communication network and system in substation, the latest. And when we talk about the advantages, of course, it is very simplified, greater reliability, future-proof design, and vendor independence. So these are some of the aspects related to IEC. Okay. Now we go into the objective, friends. Okay. The first objective, interoperability. Okay. See, interoperability in the sense, ability of IEC 61850, where exchange of data takes place between one IEC, meaning of one manufacturer to other IEDs. I think this is typo error, IED. Yeah? One IED of one manufacturer to other IED of different manufacturer in a compatible manner. So that is the beauty, interoperability. So there is no restriction on the vendors, right? Then free configuration. It supports different philosophies and allow free allocation of functions. So you can easily configure this. Then long-term stability, able to follow the progress in communication technology as well as evolving the system requirements and data storing. Common method format for storing the complete data. So these are the objectives of IEC. And of course, few more testing. It defines the complete testing required for the equipment which conforms to the standard, meaning IEC 61850. Then single standard gives a single protocol for the complete substation. Complete substation considering the modeling of different data required for substation. So it's a comprehensive single standard, friends. So these are some of the, what do you call it, objectives. Objective in the sense, what for it was introduced. So that was the target areas. Okay. Now, key functionalities or key features, yeah, increases flexibility. Benefits, yeah, rather benefits, increases flexibility, reduces copper wiring. So if you have watched my previous session, you know this. If you are not, I suggest to watch and come back to this. So reduces total installation cost. This also we covered there. Eases the system engineering and integration process. Overall, it improves the application performance and security, minimizes the cost of technological obsolescence. That is the beauty. Okay. And of course, provides easy way of implementing typical applications. So these are some of the benefits. And the last but not the least, save time and money in setup and commissioning. How and all we already covered in part 3. Okay, you can also watch. Right, friends? Right, if you are really interested. Yes. So now we go into the protocol, friends. So we have talked about the features, benefits, all this. Now we go into the protocol. So the first protocol, what is that? Goose. As we discussed, this also we discussed in the IEC, but again, for the benefit of first time viewers, I will explain this. Basically, friends, the goose, we call it as a generic object-oriented substation event. Okay, so it's a key communication mechanism defined by IEC, defined by the IEC 61850 standard for substation automation. So, what are the important aspects when we talk about goose? Okay, I'll come to this later, but I just want to, talk about something here. Okay. See, it's a fast and reliable communication. So Goose is designed to provide ultra fast and reliable communication between IEDs, that is intelligent electronic devices, within the substation. It can transmit the data within 4 milliseconds, which is very crucial for protection and control application. So that is the beauty of Goose. Then data grouping. The protocol groups various types of data, meaning such as status, values, into data sets. So these data sets are then transmitted over the network using Ethernet, ensuring that all relevant devices receive the information simultaneously. So that is the beauty. Okay, it's groups and transmits. Okay, and a publisher subscriber model. Of course, this is the one. So a standard defines the Goose protocol as a publisher subscriber model. See, basically, a publisher subscriber model is a sense, friend. This means that a device that is a publisher sends out a Goose messages, okay, and a multiple devices, meaning the subscriber, okay, so can receive and act on these messages, right? Again, I repeat. So it works on the publisher subscriber mechanism, right? Protocol, right? So this means the device that is a publisher sends out Goose messages and multiple devices, that is a subscriber, can receive and act on these messages. This model enhances the efficiency and reliability of data transmission. Okay. Then, of course, this protocol is used to exchange data between IEDs over the Ethernet. This IEC standard defines the special language based on XML to describe the post and its elements called SCL, Substation Configuration Language, which I'm going to talk this also later. Okay. So another point is in this Goose, VLAN and priority tagging. Goose uses VLAN, meaning virtual local area network, and priority tagging as per IEEE 802.1Q standard, right? This allows the creation of a virtual network within the same physical network. That is the beauty, This actually allows the creation of a virtual network within the same physical network and sets a priority level for messages, ensuring that critical data is transmitted with high priority. So that is the beauty. So VLAN and priority tagging. Okay. Then enhanced retransmission, meaning to ensure the reliability, Goose messages are retransmitted at varying intervals. For example, if a new event occurs, the retransmission of the previous message is stopped and a new message is sent out immediately. You got it, friends? See, enhanced retransmission. To ensure reliability, Goose messages are retransmitted at varying intervals. If a new event occurs, the retransmission of previous message is stopped and the new message is sent out immediately. Then, of course, interoperability. Goose messages are designed to be vendor independent, allowing devices from different manufacturers to communicate seamlessly within the substation network. See, overall, friends, the Goose protocol plays a vital role in modern substation automation, providing fast, reliable, and efficient communication for protection and control system. So that is about the Goose, friends. And here, different post levels can be described by this language. So different files can be generated. There are many, like ICD, SSD, SCD. All these are there. We will talk that in the subsequent, maybe I can cover here. Nothing wrong in that. Okay, before that, I will talk about the SCL. As I said earlier, SCL is a substation configuration language. Okay. So this plays a crucial role in the implementation of the Goose. So GOOS means Generic Object Oriented Substation Event Protocol within IEC 61850 standard. So what are all the key points about the SCL? Standardized configuration, meaning this SCL provides a standardized way to describe the configuration of substation automation system, including the communication between devices, which ensures the interoperability between devices from different manufacturers. So that is what happened here, standardized configuration. Then data set definition. In GOOS messaging, friends, the SCL, substation configuration language, is used to define data sets that contain the status and values to be transmitted. So these data sets are crucial for proper functioning of GOOS message. So that is the point. Okay. So data sets. Then communication mapping. SCL manages the logical nodes and data attributes to the physical communication network, meaning, so this mapping is essential for the correct routing and delivery of GOOS message. So that is the point. I'm going to talk about that in the next slide with the diagram, so you'll understand even more better the mapping. Okay. Then interoperability, of course, by using SCL, engineers can ensure that the GOOS messages are correctly interpreted by all devices in the substation, regardless of the manufacturer. So that's a beauty. So these are the things. And of course, engineering process also. SCL simplifies the engineering process by providing a clear and consistent way to configure and document the substation communication and control system. So this reduces the risk of errors and improves the efficiency of system integration. So this is about the SCL, friends. Okay. Now I will go into the ICD here. This one, ICD. This is very important actually. That's why I'm taking time. Okay. See, ICD. See, here we are talking about GOOS, right? So in the context of GOOS protocol within IEC, okay, 61850 standard, ICD stands for ICD, and this guy stands for IED capability description. IED capability description. Okay, so what are all the key points here? Definition, we'll talk about the definition. This ICD file describes the capabilities and configuration of an intelligent electronic device. So that is the point, IED. So it includes information about device function, data attributes, and communication capabilities. You would have seen like DD file, device description in our instruments, field instruments, right? Same way, friends. Yeah. So this this ICD describes the capability and configuration of IED, that is intelligent electronic device. Okay. Then the ICD files is used to define the data set and GOOS control blocks that the IED can publish or subscribe to. So by this, this ensures that the GOOS messages are correctly configured or interpreted by all devices. So that is the point. And it is also used for standardization. By using the ICD file, engineer can ensure that the configuration of IEDs is standardized and interoperable, thereby facilitating seamless communication and integration within the substation. Okay, so that is about the IC. Then we have a SSD. See again, friends, it's very important. That's why I'm actually taking time. Okay, so SSD stands for System Specification Description. See, System Specification Description, SSD file provides a comprehensive description of the entire substation automation system. It includes, details about the system's architecture, components, and their interaction. So this SSD file serves as a foundation for configuring the substation equipment and control system. It outlines the requirement and specification that guide the configuration of individual devices and their communication. So that is the one. So by using SSD file, the engineers can ensure that all devices within the substation are configured to work together seamlessly, enhancing the interoperability and reducing the risk of configuration errors. So these about the SSD. Then we have SCD. So what is SCD? SCD stands for System Configuration Description. Okay, so we should not confuse. SSD stands for System Specification Description, and SCD stands for System Configuration Definition. See again, friends, This system configuration definition file, SCD file, provides a detailed description of the entire substation configuration, including all IEDs, their communication settings, relationship between them. Okay. So the SCD files includes configuration of boost messages, defining which IED is published and subscribe to specific Goose datasets. So this ensures that the Goose messages are correctly routed and interpreted by all devices in the substation. So this is about some of the concept about the Goose and all these ICD, SSD, and SCD. Just remember, friends, in the instrumentation, we have this DD file, device description, CFF in the foundation field bus, right? Similar, something similar to that, friends. That's it. So this is about the Goose. So again, the Goose protocol is an event-based. The Goose protocol sends data periodically and with a specific time interval. Also, this protocol sends data in the form of a message when a special event occurs, such as stripping or closing a connector. Okay, right. So because this protocol is a publisher-subscriber type, this does not receive a confirmation after setting the message, after sending a message. But because it sends a lot of message, the chances of data loss is very low. So that is also the advantage. All the messages sent with a specific attribute and the subscriber receives only the data that requires the desired attribute. So that is the all about the Goose, friends. I hope you got some insights, okay? Right. Now we go into the MMS. Okay. See, MMS, what is MMS protocol? Okay. IEC 61850 standard defines the MMS protocol as a server client protocol. So before we talked about publisher subscriber. So this is about server client. So what is MMS? Okay. MMS is nothing but manufacturing message specification. Okay. So MMS operates on a client-server model, facilitating the communication between IEDs and higher-level entities like remote terminal unit and SCADA system over Ethernet. Okay, so it allows clients to access the server's data model, read or modify individual values, delete entries, and transfer files. This is essential for monitoring and controlling substation equipment. So basically, it's used for the data access. Okay. Then of course, standardization. MMS is defined in ISO 9506 and is based on open system interconnection model. Okay. So that is the one. And of course, wide application. While primarily we use this MMS in substation, MMS is also applied in other areas like wind power plants and also the communication between control center. So the wind power plants, the IEC standard they follow is 61400, section 25. And in the communication between control center, they follow IEC 60870, part 6. Okay. So that is about this MMS friends. And yeah, and also, when we talk about the IEC 62351 part 4 standard, it defines the security measures to protect MMS communication, mitigating the risk associated with its widespread use in smart grids. Okay. So this is about the MMS. As you can see here, friends, this is your physical device. This is your logical device. And this is your logical node. This is the data concept. And this is your attribute, data attribute. Yeah. So we are going to talk about this in the next slide in detail. Okay. So the MMS is a server client protocol. This protocol is used to exchange data between IEDs or the bay layer with a higher level than the substation layer. So the MMS protocol works on the based on TCP/IP in network platform. This protocol allows the client to read and write data. Okay. So this is about the MMS. Okay. So this is what I told. So IEC 61850 is an object-oriented standard. So here, just listen, friends. This is what's happening here. See, each physical device contains one or several logical devices. So this is your physical device. So this is your logical node. As you can see here, logical node, you have each logical device inside that, right? So on each logical device contains one or several logical nodes. Okay. So physical device, then logical device, then you have a logical node. Okay. So this is the physical device. This is your logical device. Okay. This is your logical node. And each logical node contains one or more data objects. As you can see here, this is your data objects. And each data object contains several data attributes. This is what I explained earlier. So this is the typical, look and feel, friends. Okay, right. So this name, the name of the each object is standardly named in IEC 61850. Each one is standardly named in IEC standard. If you refer the IEC standard, we should able to know the each name of the name of the each object. Okay. So that's about this. And IEC standard provides access to objects. Yes. So the IEC standard provides the possibility of collecting arbitrary data in the form of a data set. So again, I go back here. This is a data attribute, right? Yes. So this is one data set here. So the IEC standard provides the possibility of collecting arbitrary data in the form of a data set. Data set is necessarily part for a reporting block. So reporting is used to notify the client of the changes in the value of the element in the data set. Okay. So this is about the MMS friends. Just get to know the high level things. Of course, as INC guys, this is important actually. Yeah, good enough for us if you know the overall idea what is it. Then we'll see the final comparison, friends. When we compare this substation automation system with a conventional system, we can actually get the reduction in cost for operations, operational reduction cost, and up to 60% less space in the relay houses. We are using smart relays, IEV devices, right? So you can do away with the conventional and you can reduce 60% less space and shorter, 40% shorter installation phase also. Okay. Then finally, the last but not the least, up to 80% copper wire reduction because of this IEC 61850 bus. Okay. So that's all, friends, about the substation automation. My intent is to give us some overall, idea about the substation automation. I hope I have given. And yeah, thank you for your support. And yeah, see you in other interesting topic, friends. Many other interesting topics are in pipeline. And also, I also wanted to, touch upon a bit on the, solar system design, photovoltaic cell, and also the HVAC system, heating, ventilation, air conditioning. Let me know your thoughts also in the comments. You want to go for that. Yeah, so that I will also touch upon a bit on this. Thank you. Take care.